Hi, Mr. Yates here. This is part 2 of our run through of the 2019 practice exam, and we are going to be having a look at questions 9 through to question 15 or so of the calculator assumed part. After this, I'll do the third part where it'll be question 16 through to the end. So let's get started. Now, first up is a pretty straightforward one. 126 degrees to an exact radian measure. Now, always use your calculator when you can, and if we're doing exact, make sure that we're doing it standard instead of decimal. And it's just going to be 126, and it's always involving 180 and pi. And we're going to end up with a smaller number, so we're going to be dividing by 180. So it's going to be 126 times 180 times pi on 180. Remember that the shortcut for pi is Shift 0. And we do that, and it gives us 7 pi on 10. Nice and easy. It wants an exact measure, so 7 pi on 10 looks nice and clean, and there we go. So we've got our segment question right up. Theta is 126. And remember, we've got to have our angles in radian form. Fortunately, that's exactly what we have. The area of the segment, going to my formula sheet, is half r squared theta minus sine theta. And we've got radians on our calculator over there, which is nice and handy. So that's just going to be, I'm going to do 0.5 times the radius is 22 squared. And then that's going to be theta, which is 7 pi divided by 10. Take sine, shift 1 is our default for sine. 7 pi divided by 10. There we go. Make sure I've got the correct number of brackets in there. And when I do that, we don't really want standard anymore. So we'll do decimal. And that's going to be 336. And remember, we've only got this to two significant figures, so I'm not going to go for these decimal places there. I'm fine with doing that. Make sure we've got our units, centimeters squared. I'm just going to double check the answers to make sure, because it's really easy to make a little mistake there. And that's good. So, yep, I'm happy with that. And if you've got your e-activity as well, then it's easy to just use the e-activity to get that as well. What's the perimeter of the segment? So for that, we need to get the chord length, which is that length there, plus the arc length. What's the chord length? Chord length is pretty straightforward. I'll do the arc length first because that's the easiest one. That's going to be r theta, and the chord length is 2r sine half theta, or theta on 2. So we know what these are. 2 times 22 times sine of 7 pi on 10. So that's our first one. Divided by 2. Easy to forget that. Plus, and in fact I'm going to get that number, 39.2. Then it's just going to be 7 pi divided by 10 times 22 plus 48.4. Now just a little sanity check for us. Have I done the right sort of thing? Just a second, 48.4, there we are. If I've done the right sort of thing, our length around here should be a little bit longer than the length in there. And the chord length, 39.2, 48.4. Let's see what would have happened if I had not done that in there. It would have given me 35, so it would have been difficult to tell if I'd done the wrong thing or not. but it's a bit more of a clue that I have done the wrong thing. Or if you've got your reactivity, you can throw that in there as well. So that gives us, I'm just going to drag that down, there we are, 87.6. Or if you did 88 centimeters, I'd give you full marks for that as well. If you did 87.5, I'd take a mark off for not rounding correctly. And that's the correct answer there, yep, 87.6. And you've got to make sure you put your units in there as well. So that's that one there. Just a sec. It's locked on this. That's annoying. Just give me a second. Okay, that seems to have reset it. Good to remember that. Okay, so from a random survey of telephone usage in 261 households, 155 households had access to both mobiles and landlines. 54 had no access to a mobile, so and 145 households, more households had landlines than did not. This one's actually a bit of an annoying one to fill out, but 54 had no access to a mobile, so I can put a 54 down there. That means I can put in a 261, take 54, 207 on this side. For no landline, I can do take 155, I can do a 52 in there, and 145 more household has access to landlines than did not. So if we have X for landlines, and sorry, just a second, landline and no landline. So there's X in there and X plus 145 in here. We don't know what those numbers are, but I can go X plus 145 plus X equals 261 and solve that. It's under solve, and X is 58. So we've got 58 in here, 58 plus 145 in there, so that's going to be 203. And then let's just do the rest of it. 203 minus 155 is 48. Then that will be 6 in here. And there we have it. So that's our completed diagram. The hardest thing is working out this little bit here. And if you ever get completely stuck here and don't know what to do, just put in some random numbers or numbers that seem about right. Because if you can't get these ones, you can't answer the rest of the question, and so it does make it more difficult to work out what's going on there. So just make sure you've got something in there, and if you've got something in there, you might be able to work out the rest of it as well. Even if your answer's wrong, just having something in there gives you numbers to reference for this next bit, which is where a lot of the marks are as well. So if one household is randomly selected from those surveyed, what's the probability it had access to a mobile phone? So that's 207 out of 261. Now it's good to do the decimals for these ones, if only because later on you might need to answer some other questions relating to independence and the like. So I'm going to do that and do 0.793. I would do at least 3 decimal places for these. It had no access to a landline, given that it had access to a mobile. So for these ones, I like to remember that when we're dealing with givens, we're looking at only this section of the data. We're looking at the universe where everyone has a mobile. We don't care about these ones. So no access to a landline, that's going to be 52 out of 207. And that decimal is 0.251. Technically, I should put approximates here because these are approximations, not exacts. But that's good there. This is enough to get the full mark, but we're going to possibly need other bits to let down later on. It had access to a mobile, given it had no access to a landline. So that's 52. So given it had no access to a landline, that's this one. So the given thing, that's what we're looking for. It had access to a mobile, that's 52 out of 58. That's going to be 0.897. Now, use your answers above to comment on the possible independence of households having access to a landline and households having access to a mobile phone. So, if they are independent, the probability of landlines, just a second, given mobiles should be the same as the probability of landlines. So basically, having a mobile phone does not affect it. So if independent, probability of a landline given a mobile is equal to the probability of having a landline. Now, this is our probability of our landline given mobile. This is no access to a landline given a mobile. So that is the opposite, the complement of that. No access to a landline given a mobile. So probability of landline given mobile is going to be 1 take 0.251 is 0.749. So what's the probability of having a landline? Is, just a sec, probability of having a landline is 203 over 261. Equals 0.778. So because if these were had at least 2 decimal points that were the same, then I would be inclined to think that, yeah, they're probably independent, or they're close enough to being equal. But the probability of that given that does not equal the probability of a landline, therefore they are not independent. And there we have it. So there's a whole bunch of ways we can determine independence. We could have also done the probability of landline and mobile should be equal to the probability of landline times the probability of a mobile. There are lots of ways we can do it, but I like to think of it this way as well. So, and there may have been a way to do it without having to calculate anything new, but I just wanted to just get some extra ones there. So there we go. So they are not independent because the probability of a landline given a mobile was not the same as the probability of a landline. Independence is like if you roll a die, the result of your first die does not impact the result of your second die, and that is independence. They are independent of each other. Next up, question 11, we got a drone. Drone is flying in a straight line at a constant height. There it is, flying along. And above a pitch towards a thin goalpost, it maintains a constant speed of 4.5 meters per second. Initially, the angle of depression from the drone to the base of the post is, let's try that again. So initially, we've got 8 degrees. Then exactly 3 seconds later, this angle has increased to 10 degrees. So there's our diagram. I did that as I was talking about it, but it does want us to sketch a diagram there. And that was 3 seconds later. So if it's 3 seconds later, this is going to be 3 times 4.5, that is 13.5 meters. Now, that's what we've got here. We've also got a right angle. There we are. And that's the height h. So we want to find the value of h and the time that the drone will collide with the post. So we're going to need to find h. We're also going to need to find this distance over here. There's a few ways we can do it. Now, one way is to recognize that we actually have a, what is it? So we've got a triangle over here with 170 degrees, and we can actually use our cosine formula. We then work out that this is 2 degrees over here. We can use the cosine formula to work out this part of the triangle there, and from that work out the other ones. Or we can look at the fact that we've got two right-angled triangles and solve that using some simultaneous equations. I'm actually going to use the simultaneous equations method and see what we can work out there. So we've got one right-angled triangle. So if you've got your ClassPad solver, you can also solve for this triangle here, work out what this is, and go from there. But I'm just going to use simultaneous equations. So what we've got h, or what we've got is sine of 8, oh sorry, not sine, this will be tan of 8 degrees is going to be opposite, which is h, over adjacent, which is 13.5 plus d. Tan of 10 degrees is going to be h over d. So what we need to do is we use solver, and it's fine to just say we're using solver. We get out this, we do use simultaneous equations there, and make sure I've got my thing set to degrees because we were looking at radians before earlier in the piece. So I'm going to do tan, that's shift 3, tan of 8 equals, and I'm going to use my proper variables here. That's going to be h divided by 13.5 plus d, just so I don't confuse it. I could use x and y because they're just available on the keypad there, but I'm actually going to use h and d just to make things exactly clear what I'm doing. Tan 10 equals, let's close that bracket, h divided by d. You've got to tell it what you're working with. We are working with h and d, so we put h comma d in there. What have we got? H equals 9.35 meters, rounding to 2 decimal places. Doesn't ask what to use, but D is equal to 53.0 meters. So there we have it. So now that's not the end of our questions. We've got D, H there, D there, but we've got to find the time at which it collides with the post. So we want to add 13.5. That gives us 66.5. 66.5 divided by 4.5. That gives us 14.8 seconds. So it'll collide with the post after 14.8 seconds. Let's just double check that I've done the right thing there. Lots of ways to go wrong with this particular question. Yep, 14.8 and 9.35 are our answers there. So there we go. Because remember, there's two things to solve with this one. That's why it's worth 6 marks. Okay, let's have a look at the next one. Manufacturer makes X litres of a chemical using process X. The cost varies like that. What's the cost when 35 litres is made? So that's the cost per litre. So 35 litres is made. That's going to be 240 over 35 plus 15. 240 divided by 50. But we've also made 35 litres, so we've got to multiply it by 35 as well. $168. Oh, sorry, that's not yet. Sorry, I'm getting ahead of myself. It's actually for the next bit, 240 divided by 50. It's $4.80 per litre. So the total cost, and they're actually nice enough to point out that it's total cost and to give you a practice one ahead of time, of making 17 litres, that's going to be 240 over 17 plus 15 multiplied by 17. That gives us $127.50. Make sure you do two decimal points when talking about money. Otherwise, your answer doesn't make sense. There's a nice little pun for you. Okay, if you got this far in the video, you've earned it. Okay, so next up, graph the cost per litre. That's 240 over x plus 15. Remembering that the range is 5 to 45. So we're actually only going to go from this point to this point. If we draw outside of that range, we are going to lose marks. So that's going to be 240 divided by, let's get this out of the way. In fact, let's draw it on that. 240 over x plus 15. Sketch that. Set my range. It's going to be 0 to 50 on the x. And I'll do a scale of 10. It's going to be 0 to 20, I'll go. And I'll do a scale of 5. Here we go. Sketch that in there. That looks good. Analysis, we want to find the y values when x is equal to 5. So when x is equal to 5, y is equal to 12. That's a point there. We also want to find the y value when x is equal to 45. That's going to be 4. And we've got a few other values up here. At 35, it's $4.80. So, let's just do another one for good measure. X equals 20. X is 20, y equals 6.85. So that's going to be around about there. Oops. There we go. So we've got a rough line looking like that. Just so long as it's pretty clear that it's a... Oh, let's try and make it a fairly smooth curve. It's part of a reciprocal function, and because it's divided by x with the asymptote shifted 15 over to the left. but we should get something like that. But if you've marked out your points and you haven't drawn it outside of the range, then you should be good. So what's the range of Cx? The range is what we've got. So that's going to be, so the range is what our y values can take. So range is such that it's between 4 and what was our maximum? 12. And that took us a second because we've already done the work earlier. So we got another process, process Z. The cost in dollars per litre is that here. 10.5 take x on 6 between 5 and 45. So let's do that one. 10.5 take x divided by 6. Whack that on what we've got there, whack our other one in there as well. The production quantities, there we are, 12. So what are the production quantities for which it's cheaper? We find our intersection, 15 and 8. So here now I may realize that my graph is actually terrible. So we got 15 and 8, and we got 33 and 5. So I can draw a straight line joining these 2 points for my second function. And then, oh, come on, what's going on? There we are. And then, oh, actually, we've got to make sure it does not go outside our range again. Here we are. And our blue line should intersect with those 2 points too. Oops. So something like that. Anyway, if you've got something better than I have for drawing, then you'll have an easier time of this than I'm currently having. This is a very finicky one to try and draw. Clearly this line, this one I've drawn up here, is a little bit on the wrong side. So there we are, I've deleted that successfully. So that's what we've got there. X is cheaper than Z. For and it's going to be between 15 and 33 litres. So when X is between 15 or 33, oh wait, sorry, which one is which one? Oh, that's process Z. Process X is the green line, so yeah, so it's between 15 and 33 litres. Process X is cheaper, otherwise it's process Z. And let's just have a look here, make sure I've done that correctly. Yep, there we go, that's correct. Next up, question 13. The graph of y equals f of x is shown, where f of x is 3 to the power of x, together with the secant to the curve. Now, just so you know, just as a reminder, when we talk about the tangent to a curve is the straight line that just touches through it without actually going, without passing it through it more than once. A secant is a line that does pass through it twice, like that. That is a secant. It passes through the line twice. A tangent just passes through it once. So we've got that there. That's what a secant is. Goes through the points P and Q. P has coordinates 1, 3, and Q has coordinates 1 plus h, so it's gone across by h, and then it's gone up. Now this is going to be a hint for what the kind of question we're doing. We're doing one of these annoying first principles type questions. So what we want to do for this kind of question is be very careful about how we set up our equations. So remember what we're finding, f of 1 plus h, take f of 1 over h. We are finding the gradient for these. So that is rise over run, how much it's going up by divided by how much it's going across by. So what I'm going to do is I'm going to set up my equations very carefully. So f of 1, so we've got 3 to the power of x. F of 1 equals 3. F of 1 plus h is going to be 3 to the power of 1 plus h. So I'm going to set up my equations very carefully, and it's going to do clear all. There we go. And I'm going to set it up as a fraction, and it's going to be 3 to the power. In fact, I'll even put the correct symbol in there. 3 to the power of 1 plus h, take 3, divided by h. So I've set that up there correctly, and if I want, I can write that in here, 3 to the 1 plus h, take 3 over h. Now what I want to do is, if I've set this up correctly, I can save myself a lot of time. I go to Math 3 and do the vertical line. Given, that is our given symbol. So it's given that our variable, you could have done x as well. Oh, where'd that go? Given h equals 1 for our first one. Given h equals 1, we get 6. Now that'll be the gradient for this. As we get smaller and smaller, what we expect to see is a gradient that becomes closer and closer to the tangent. So we expect it to get a little bit lower. So let's see if that ends up happening. So let's try 0.1. Now obviously, if you've set this up properly, it makes it a lot easier. Then we've got 3 point, and it says 4 decimal places. 3.4837. Remember to make sure we're doing the correct decimal rounding there. Add an extra 0 in there. 3.3140. Add another 0 in there. Just a sec. We've got 3.2976. And there we go. Now, what feature of the graph above that the values I calculated represent? It represents the gradient of the secant as h changes. Now, the next thing we need to do, this will probably have to be the last question I do for now. So, determine an estimate, correct to 3 decimal places for the value that h approaches. So I'm going to put a few more zeros in here and see what we've got. 3.296. See if that stays. If I put another 0 in there, it's still 3.296. So 3.296 is an accurate value. And we can tell that if it doesn't change any of the decimal places when I add an extra 0, then it's most likely accurate. What does this represent? This represents the gradient at f of 1. So that represents the gradient when 3 to the power of x the gradient for 3 to the power of x when x equals 1. Okay, I'll stop off there for the moment, and we'll do the rest, question 14 onwards, in another video. And there we go. Have a good day. Bye.